Alright, so welcome to Machine and Mechanism class. So today our lesson is continued but with practical. So you can view our course materials on VLE, and we've got textbooks, we've got lecture notes for the past 2 weeks where we have touched on introduction and also kinematics diagram, and also we did live using position analysis. And also we need to do review on rotation on a fixed axis. So today we have to start our practical lab. So you can get all the materials for our practical labs here. There is this PowerPoint and also folder for your files for our practical one. So at the end of our practical, you guys are supposed to do about 3-minute video presentation for your practical. So there's no need to send any PowerPoints whatsoever. You just record on your screen your video what you have done, or just use your mobile phone and upload here. So let's start. So once you have downloaded everything, you can see this folder. Inside this practical one CAD files, there are 3 folders. So inside here, we're going to be start doing worm gear first. So open up worm gear folder. Before we open up here, we need to power up our SolidWorks 2016 and create file new. When you get to this page, you have to select assembly. Click OK. So on assembly view, you're going to see something like this lah. On the left hand side, there is something called begin assembly. You can create a layout, or you can just browse to the particular part that you want. So let's go ahead and browse. So look for worm gear. So this is our first part that we want to do. Obviously, you can make this thing bigger by changing views. You can choose large icon or extra large icons. Let's go for extra large. So over here you can see there are 6 parts that we are supposed to assemble and make it interact with each other. So the first part that you should use is it should be the main part. It should be your fixed part. So the first part I'm going to choose is this one, modified housing. So by default, if I choose modified housing, yeah, I can put it anywhere, and this will be my first part. So your first part, if you view here, you can see that there is something called F. There's this F and then in a bracket. So F in a bracket means you cannot move this part. This part is fixed. This part is already fixed here. If you want to move this part, you have to right click and then you click on float. If you click float, you can move this part. However, the default is the first part is fixed lah. So how do you fix this part? Right click maybe. Yeah. Click on the part, right click, and then click on fix. So this thing will turn back to F. So your first part should be fixed lah. And then we're gonna create insert components. You can insert components, browse. It's going to go to the same folder. You can select many things, maybe 5 things. Just click on open. Now we can put your parts somewhere around the main assembly area. This one, there is something called configuration. This one you can just choose default lah. If you choose others, you can change dimension lah. So configuration you can use for parts with different dimensions. Just use default. And then this one also you can choose. Never mind, just choose default 2.5. Okay, so you've got this part. And now you are going to be assembling this thing. So before we get too further, let's open up our PowerPoint. This is our main PowerPoint. And yeah, you can see over here some SolidWorks assembly tricks. This is probably useful. Click Control to select multiple items for assembly. Okay. Left click to move. Right click is to rotate. So let's try a few of them. Control. I think control is to yeah, this one is to pan, move. And then you can rotate using right click. You can rotate items using right click. Pan item is move is to just click lah. Can you click and then control drag? You can duplicate items. You can click the item, control, drag. You're going to multiply the items lah. So now you can delete. Confirm delete? Yes. Confirm delete? Yes. So two things. Click control, left, right click. Always assemble main item on assembly coordinate system. Okay. Float the item to make the first item free. Control to duplicate items. You can use physical dynamics. We can use later on this one. Okay, not much. So let's go to this part lah. This is the reference diagram that you should view. You are going to assemble all this thing and you are going to apply something called mid gear. So let's continue. Number 1, we are going to assemble this one. This one, I can click on mate, and then I can choose this surface, and then I can choose this surface. Coincident. So now what happens is I cannot, yeah, it will be coincident. Next, maybe I should choose concentric of this hole, this circle to this circle, and then accept. So now this thing is rotating like this lah. Next, probably I want to do concentric this one to this hole. So now it is okay already. Next, what should I do? I'm going to assemble this cover. Let's look at this thing. So you've got two covers, left and right. So I need to multiply this item lah. Click, and then click control and then drag. So you've got two items lah. So let's click on mate. Mate is the command, is the feature that you use to assemble things. Sometimes you don't have to click on concentric or whatever. If you click on a circle and then you click on another circle, it will automatically choose for you concentric. So you can either, so this one is accept lah. So can I still rotate? Yes, it can still be rotated like that. So what I should do now is concentric another hole. Mate, concentric, I think this hole to this hole. So it is aligned lah. Two things are aligned. You cannot rotate it anymore. It is like that, but then you have to make surface. So click on mate, choose something called coincident. coincident this surface to this surface, and now we're good. Next will be this one, so you have to repeat the same process. Number one, if you want to make this easy, maybe you want to rotate. If you want, rotate. And then choose concentric, this circle to this circle, then concentric again, this hole to this hole. Finally, coincident, this surface to this surface, accept. Okay, so how are we progressing? I need to put this thing is slightly offset. This hole should be at the bottom. But then you guys can correct this if you want. I guess it's okay. Next, I need to put a shaft. What kind of shaft should I put? Gray color shaft, put in the center. So this is a gray color shaft. Let's put it in the center. Made. Obviously, circular items, you select concentric. So this is a circular item. Select another circular item. So we have one constraint done. So this thing is here. You can move it there. It should be coincident to this surface. So next will be coincident this surface and this surface. You okay? Okay, I think we're done. What else? Red color shaft should be inside there. Concentric this red color to this circle. Accept. So this thing is still movable. I should make it drag it out. I should make this same surface. So should it be coincident? Let's try. Mate. I think this one should be, it's already parallel. Coincident I think. This surface to this surface. Yeah, you can still rotate. And it's already coincident with that one. Make sure your shaft is still rotating. Yeah, it still can rotate. I think we are almost done with all the parts except the last one. So the last one is this pulley. This pulley we need to put it inside there. So if you cannot see inside, one thing that you can do is you can do a section view. Click here, section view. You can change the location of the section view by dragging this icon. Maybe you want to select here. You can even change the planes. This plane, or this plane. So this will be great if you want to work inside. So this is the internal, and then click accept. So you are working with the section view already. This thing can still rotate as usual. So let's insert this thing. Inserting this one is just using one command which is mate. Click on mate. Select concentric. Select a cylindrical surface. This one. Select another cylindrical surface. Maybe this one. So it is inside. So click on. Yes, accept. However, this pulley is moving along the shaft. So what you should do now is you should do something called mate, and then look at something called advanced mates. advanced mate. Under here you can see something called width. So choose width. So with this width selection, you are supposed to select pairs. So the first pair is this distance to this distance, and the next pair is this one to this one. So it will align it to be in the middle. Okay, so this thing can rotate. So if you miss that out, maybe you can repeat the video lah. So you can choose width. So whatever we've done inside our mates, everything is recorded in history. You have so many constraints here or mates here, and this last one is in width lah. So I'm going to show you again width. I can delete this width. Right click. I can click delete. If I delete this width, this thing can travel. So I'm gonna do mate width again. Mate. I'm gonna choose advanced mates and then choose width. So for the pairs, it doesn't matter. You can choose this pair 1 and 2, and then choose another pair. This one and this 2. It will go to the location which is intended lah. I think we're done. We're almost done probably. So now what we want to do is, this thing is not rotating with this shaft. What do we do? Let's check out what is the coincidence here. I think this one. Right click, we can edit feature. This one you can choose something called lock rotation. Now let's try. Yeah, this shaft, when you rotate, the whole thing will rotate together. So this one is something called lock rotation. So next thing we want to do is, when we rotate this red color shaft, we want this thing to rotate. How do we do that? We should do something called mate, mechanical mates. Can kah? Advanced mate? No, mechanical mate. Mate, and then choose mechanical. We should choose something called gear. So the reference for this is just radius lah. So this one, and then this one kah? This is not valid lah, because this is not the good radius lah. You can use a circle, this circle. The ratio you can change here using the correct ratio lah. Let's try. If I rotate this one, yeah, this thing will rotate. Okay, let's circle back and analyze this and make this proper. Okay, I'm gonna turn off this section view first. See, number one, when this thing is rotating, the whole thing rotates. If you cannot see inside now, maybe you want to change transparency. This is a housing, right? This is the housing. How do I change the transparency? I can suppress or change transparency. If it's change transparency, can I see inside? If I rotate this thing, yeah, you can see inside. Transparency change also can, or you can use a section view, modified housing. I can change back the transparency back to opaque lah. Okay, we haven't done this properly. Mate for gear is not being done properly yet. Let's edit this feature. There should be a proper ratio. How many mm to how many mm. This one you have to check the radius. Radius of the shaft or the diameter of the shaft. Let's say, let's inspect what is the mating diameter. Let's open up section view again. Okay, this is fine. Okay, we need to do this properly. I'm going to open up, let's insert a new slide blank. Let's draw something. Okay. So I think we have learned in rotation on fixed axis, if you have a smaller gear and you have a bigger gear, this one is R1, this one is R2. So the relationship is omega is equal to, no, the relationship is V is equal to omega R. V meaning you have common velocity, right, at the point of intersection or at the point where the gears are in mesh. Gears in mesh. So we get this equation lah. And another equation that we always use a lot is this one lah. So this one, the common velocity, common tangential velocity. So omega 1 R1 is equal to omega 2 R2. If you want to change this to diameter also can. Omega 1 diameter 1 equals omega 2 diameter 2. So it doesn't matter lah. So you have to get the dimension or the diameter. So we have to analyze our model lah. Never mind, keep it. Let's analyze our model. The smaller diameter is how much? How to check? Click on this one, evaluate. Click on measure, choose. This one diameter is 15.24. So you have one data. 15.24. Draw. Smaller one is diameter 15.24. How about the big one? The big one is, let's check. How do we check? This one lah. If you think that it is so hard to investigate this one, you can click on the part. What part is this? Worm gear. This one lah. Worm gear, you can even open up the part. Right click and then open up the part. So this is the worm gear. So at the point of what is the radius of this worm gear? So how do you evaluate that? You have to refer back lah to your worm gear. What is the diameter? This correct one. If you want to investigate, you can click on evaluate and then just measure. This one's in inchy. So can change this one custom, change to millimeter. Measure. Perimeter area. Measure. This one you have the diameter lah, but this one is the big one. 62.427. 60. This one. That's how you measure correctly. We are supposed to measure at the point where your gears are in mesh. What is the radius at the point where your gears are in mesh? If you find it hard, maybe select on the original part what is the dimension. You just click on measure and then measure the particular diameter. So let's say for practical purpose, this one, for example, the diameter is 50.8. So let's say this one you have to refer. This one is 50.8 mm. So these are the two dimensions that you're supposed to input here. Window, go to this one, assembly 2, right? This is the one. Go to our mates, gear mate, edit feature. 15.24 is given already. 59 mm is the one that we decided. So this one you have to put the one that we measured, 50.8. 50.8. So if you do that, everything will be correct Window, worm gear. Can we close this one? File close. Worm gear is missing. Let's open up. Let's regenerate. Okay, so now if you rotate this red circle, your assembly will also rotate. So this is what I want you guys to do I can complete this in about 15 minutes. So take a video, show that you can do this. So next item. I think I can close this one. Make sure you take a video first because you need to submit. Or save save as an assembly. Put somewhere as practical one. Put practical one. Save. So now I can close file, close the whole thing. And now we're going to move on to our next practical. Next practical is this one. It's something called a universal joint. So in this universal joint, you have some sort of like a crank. And this crank, when you rotate, the whole universal joint will rotate together. Okay, so let's open up. Make sure you are now in the folder of this one, U-joint. So in this U-joint, you have 8 parts to assemble. Let's open up SolidWorks, File, New. Again, Assembly, click on OK. Create layout, Browse. Browse to the second one, which is U-joint. So U-joint, now let's change to extra large icon. Obviously, the first part is the main part. Is your fixed part. So I'm going to choose this one, this bracket. So this bracket is my main one. Apparently, we can do this rotation. You can even rotate whatever angle you want. Z-axis, you can even rotate 90 degrees. So this one is good actually. I'm gonna put it there. This one will be turned to fixed F. So all the next items I'm gonna select You can go to here, assembly, insert components, browse to the rest of the parts. So we've got 2, 4, 6, 7, all 7 parts 7 is not that much. I can populate my desktop Yeah, this one has got a configuration. Never mind, take the first one, and then this one, and then this one. I guess that's all. Bring it slightly closer together. Okay, look at my PowerPoint. I am supposed to assemble this crank first. Let's assemble the crank first. This is the crank. I'm going to put this thing here. So mate, not insert component. Mate. I can select a circular item, select another circular item. It will automatically select for me concentric, and then click on accept. So I need to shift this up a bit, and then I need to coincident lah. Coincident which one? Coincident this surface to this surface, so that it will be resting on each other. So that one is okay. Obviously this one needs to go inside here. Obviously. So this circle, you have circular surface and you have a flat surface. This is the best. Mate concentric circular item, put in the circular item, and then click on accept. Next, maybe I wanna coincident this surface to this surface. Accept. So now it's okay already lah, but then it still moves. So typically you need to do it 3 times lah, typically. So you can constrain X, Y and Z motion. Put this like this, or coincident one more time. Coincident this surface to this surface. So now it's inside. Yeah, it's okay. If you don't like it, you can change transparency. If you want to look inside, right, whether you have assembled it properly. Is there any clashes? Is this clashing? Check using section view. It's not updating yet. Never mind, turn this one. This item, crank, right click, transparency. Apparently it's okay lah. Apparently it is resting properly. So transparency. So this one is good. I'm going to put this one inside here. How to do that? Choose mate concentric this surface to this surface. Click on OK. So this thing will rotate however it goes up and down. What is the dimension that I should put? This one. What is the dimension? Refer here. You have some gaps. There is some gaps here. So never mind. Put it afloat first. Let's assemble another thing first. Let's put this thing here. This thing here. Okay, so obviously concentric circle to circle assembly. This one goes up like that. You obviously need to make this surface, this flat one, right, to this flat one. It is selected for you. This is coincident, and then click on OK. So when you rotate this crank, the whole thing rotates together. Next, you want to rest this bottom here, right? So mate again, if you select this surface and this bottom surface, it will automatically select coincident for you. Now we are okay. This is being assembled like this, huh? Now let's coincident again. Mate coincident this surface to this surface. Rotating, rotating. So this one is okay already. Next thing you want to do is assemble this one. Rotate. Remember how to rotate? Use right click. Right click will rotate for you. This one. Let's mate and concentric this hole to this hole. Are we okay? This one is like this. What else we should do? It should be rotating like this. Should be like that. So this one rotates like this. So we need to, I think one more, coincident. This surface to this particular face. So this thing is rotating like that. Okay. So at this point you have made some progress. So you might want to save as. Choose practical 2 kah? It's actually practical 1 juga lah. But part 2. Next, we want to put this one here, inside here. And then we want to put all these circles inside here. How do we do that? Obviously, we need 2 pins. 2 pins. Can we put this pin inside here? Or you want to assemble this one first? Both ways works. Assemble it inside first. Mate this circle to this circle. It's good. And then mate this circle to this circle. Becomes like that. However, this thing moves. So you need to do something called width. Like the one that we did last time. Width. So you can go to advanced mate. Choose width. This line to this line. Width with this line to this line. So it will become center. Okay, so it is like that already. This one, I think I need to delete this part. This part, delete. Yes. I'm gonna recall another part. Browse. Pin. However, I need to change the configuration to short. Short pin. This pin, click Control and then you can duplicate this pin easily. So mate concentric this one to this circle, this one to this circle. However, this thing is moving, still moving. How do we do that? If you want to put this touching together like that, how do you do it? since you have this circle, so something like this, maybe you want to use something called mate tangent. Choose this one, tangent. So you want to tangent this surface to this circular surface. Becomes like that. You want to tangent again this flat surface to this circular surface. So it becomes like that. How do we look inside? Section view, change planes. This one is good or gone. Section view, drag it. Can you see the internals? This one is good. You can see the internals. This thing is mating and touching together there. Okay, so section view works lah. Make your life easy. So next thing is you want to insert this to here and then try to rotate the crank. How do we do this? Mate circle to this circle. The default mate type tangent would over-define the assembly. Okay, let me change. Mate this circle, change concentric to this one. So it is like that. Okay, so if you feel that your assembly is overcrowded, you can hide certain things. Bracket. This thing is overcrowded. I can hide this one for a while. This one, hide component. This bracket, hide components. You want to assemble it one by one. Doesn't want to make your life hard, right? Hide things. How do you put this in the center? Is this clashing already? I think you can tangent also. Let's try tangent mate. Tangent this flat surface to this circle. Okay, so this one is done. Is this one done? This one is okay. How do you unhide all the parts? Unhide. Okay, look at this one. There's this thing. So this one you can open back the eye lah. Show component. Show component. So everything is open. So you wanna hide this one. Right click this one and then hide. You may wanna hide the bracket. Hide the bracket. You rotate. Okay, this one can rotate. How do I? Kinda hard, Mate coincident. Concentric wrong. Concentric. This circle to this circle. The component cannot be moved to position which is made. So they're not parallel. Okay. Let's try. Let's open up this one again. What is the problem? It's not parallel. Kalau not parallel, there's something wrong lah. Mate concentric this circle. This circle to this circle. Cannot do that. Never mind. We can do something that will make it. Sorry, this one. Okay, this one coincident kan. Maybe you want to delete this first. Make it free a bit. Now we made it, and then we concentric this circle to this one. Now it's okay. So let's open up the bracket. Let's open up the bracket. So now, yeah, so now it's okay lah. Yeah, so you made it. Sometimes you need to relax things, huh? Rotate, the whole thing rotates properly. So this is the thing that you want lah. So record that you have done this. You can do this, and then submit to me, showing that this can be done. So in all your designs, everything that moves has to move according to the mechanical. Anything that moves. So this part is done lah. So file, save, rebuild the document. It's good. So let's move on to the next part. This one, file, close. Next part is the hardest one. In the next part, so you've done few things, right? You've done this one. You can do some assembly. So you have to look at these gears. Just now we were talking about the diameter. What is the diameter where it is mating? Universal joint, you've done this one. This one is good. Finally, we're going to go for something with a few types of motion. So you've got linear translation, you've got curvy linear translation, you have learned about rotation on a fixed axis, and there is something called general plane motion. So general plane motion is one of the hardest kinds of motion where you have rotation and also translation. You are combining this one combine this one plus this one. So in application, which is most common, is something called piston and crank. So this is the hardest part that we're going to do today which is how to analyze crankshaft piston motion. So you've got 1, 2, 3, 4 crankshafts. So we're going to be doing this next. Discard.